Standard 12, exercise 8.10. At the given point of time, the earth receives energy from sun at 4 calories centimeter square per minute. Determine the number of photons received on the earth's surface of the earth per centimeter square per minute. Mean wavelength of the sunlight is 5500 Armstrong. Okay, so here the energy received from the sun is 4 calorie per centimeter square per minute. Okay, and the wavelength is given as 5500 Armstrong. Okay, now here it is given in calories. So total energy received is equal to 4 calorie per centimeter square per minute. Okay, so what is 1 calorie? 1 calorie is 4.184. So we can convert this here into 4.184 per centimeter square per minute. Okay, so that is 16.74 centimeter square per minute. Okay, now what is the energy of one photon? That is E is equal to h nu. So hc by lambda. So it is 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by 5500 into 10 raised to 10 minus 10. Okay. So if you multiply this, you will be getting 19.878 into 10 raised to minus 19 divided by 5.5. So you will be getting it as 3.6 into 10 raised to minus 19 joules. Okay. So this is the energy of one photon. So number of photon is equal to total energy by energy of one photon. So what is the total energy? Total energy is 16.74. Okay. By 3.6 into 10 raised to minus 19. So you'll be getting it as 4.65 into 10 raised to 19 photons. Okay. So that is your number of photons value. So this much of photons are received on the surface of the earth per centimeter square per minute. Standard 12, exercise 8.9. A 3310 Armstrong photon liberates an electron from a material with energy 3 into 10 raised to minus 19 joules. With another 5000 Armstrong photon ejects an electron with energy 0.972 into 10 raised to minus 19 joules from the same material. Determine the value of Planck's constant and the threshold wavelength of the material. Now here, lambda 1 is given as 3310 Armstrong. Okay, and lambda 2 is given as 5000 Armstrong. And kinetic energy 1 is given as 3 into 10 raised to minus 19 joules. And kinetic energy 2 is given as 0.972 into 10 raised to minus 19 joules. Okay, now we have to find out the Planck's constant and the threshold wavelength, lambda 0 value. Okay, now you know the formula, Einstein's photoelectric equation plus kinetic energy. This is the Einstein's photoelectric equation. H nu plus phi 0 is equal to phi 0 plus kinetic energy. Now I can write this as hc by lambda 1 is equal to phi 0 plus kinetic energy 1. This I will take it as equation number 1. hc by lambda 2 is equal to phi 0 plus kinetic energy 2. This I am taking it as equation number 2. Okay, subtracting 1 minus 2. So hc by lambda 1 minus hc by lambda 2 is equal to kinetic energy 1 minus kinetic energy 2. Phi 0 will get cancelled. So you will be getting hc into 1 by lambda 1 minus 1 by lambda 2, which is equal to kinetic energy 1 minus kinetic energy 2. Okay. So this can be written as okay. We have to find out H. So H is equal to kinetic energy 1 minus kinetic energy 2 by C into, this can be written here as lambda 1 lambda 2 by lambda 2 minus lambda 1, taking the LCM. Okay, so now we will substitute here. It is 3 minus 0.972 into 10 raised to minus 19 divided by 3 into 10 raised to 8. This is into 3.31 into 10 raised to minus 7 into 5 into 10 raised to minus 7 divided by 5 minus 3.31 into 10 raised to minus 7. Okay. So here this, if you subtract it, you will be getting as 2.028 into, if you multiply these two, you will be getting it as 16.55 into 10 raised to minus 34 divided by 3 into, if you subtract this, you will be getting it as 1.69. Okay. So it is 2.028 into 16.55 divided by 5.07 into 10 raised to minus 34. So you'll be getting the H value as 6.62 into 10 raised to minus 34 joules second. So we have found out the H value. Now we have to go for the work function. Phi 0 is equal to Hc by lambda 1 minus kinetic energy 1. So it is 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by lambda value is 3.31 into 10 raised to minus 7 minus kinetic energy is 3 into 10 raised to minus 19. So if you multiply this, 19.86 into 10 raised to minus 19 divided by 3.31 minus 3 into 10 raised to minus 19. So if you divide this, you will be getting 6 into 10 raised to minus 19 minus 3 into 10 raised to minus 19. So you will be getting the value of phi 0 as 3 into 10 raised to minus 19 joules. Now from this we can go for finding the threshold frequency. We have to find out threshold wavelength. So lambda 0 is equal to Hc by phi 0. So it is 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by 3 into 10 raised to minus 19. Okay, 3 and 3 will get cancelled. So you will be getting it as 6.62 into 10 raised to minus 7 meter, or you can write it as 6620 into 10 raised to minus 10 meter, which is 6620 angstrom. This is your threshold wavelength.